Okay, in this video we're going to wrap up section 1.1. That's graphs of equations. And the big thing today for today is circles. And this is probably something you did not see in Algebra 2. So consider the circle shown in the figure here. A point xy is on the circle if and only if its distance from the center, h, comma, k. Here's our point that is the center, h, comma, k. If its distance is r for the radius. So how would we find the distance between this center of the circle at hk and this point on the circle at point xy? Well, we could just use the distance formula that we had at the end of chapter P, section P7. We did the distance formula, and that was our big square root of, our x coordinate minus another x coordinate quantity squared plus y coordinate minus y coordinate quantity squared. That was the distance between the points, and because, one point here is at the center and the other is on the circle, we can call that distance our radius. So we want to come up with the equation of a circle. So we're going to square each side of this equation. So if I square this left side, the square and the square root will cancel, and I'll just have what's under the radical. X minus h squared plus y minus k quantity squared is equal to r squared. And that is our standard form of the equation of a circle. So the point xy lies on the circle of the radius r and center h, comma, k, if and only if this is true. H and k are the center of the circle, and this is the radius squared. And the x and y are just x and y. So from this result, you can see that the standard form of an equation of a center or a circle with its center at the origin. So if your circle is centered right around the origin, then the h and k would be equal to 0. So this would be x minus 0. Oops. This would be x minus 0. This would be y minus 0. So we would just have x squared plus y squared equals r squared. And that is a circle that is centered around the origin. So here, the book didn't have a whole bunch of really good examples, so I just found a couple in the back of the book that were not assigned for homework or in other sources. So here in this first example, find the center and the radius of the circle. And then it does say sketch the graph. Yeah, we'll even do that too. Alright, to find the center of the circle, remember it's x minus h and y minus k. So just look at this number, x minus and y plus. I tell students to find the center of a circle, it's going to be a point, an x, comma, y coordinate. When I look at this, I even tell the students to look at the sign and switch it. If this is a minus 2, you bring down a plus 2. If this is a plus 3, you bring down a minus 3. That is the center of the circle. If we want to find the radius, remember this is all equal to r squared. So the radius squared equals 16/9. So to find the radius, we square root. The square and the square root cancel. And we're going to square root the numerator. The square root of 16 is 4. And we're going to square root the denominator 9. The square root of 9 is 3. So the radius has a length of 4/3 units. And if we wanted to do a quick sketch, I'm going to just draw a quick x and y axis. I know my center is at negative 2 or 2, negative 3. 1, 2, and negative 1, 2, 3. There's the center of my circle. And the radius is just a little bit more than 1. If we make that into a mixed number, it'd be 1 and 1/3. So my radius is just going to go up to about here, maybe down to here, 1 1/3 in each direction. That would be my circle. And you can tell it doesn't cross the x-axis or the y-axis either. In this exercise, we're going to write the standard form of the equation with these given characteristics. So here we had the equation, and we came up with the center and the radius, and we even sketched a little graph of it. Now they're giving us the center and the radius, and they want us to write the standard form of the equation. So remember, it's x minus h squared plus y minus k squared equals r squared. And now we just have to plug in, the relevant pieces. So here is x minus, with this, our center's x coordinate is a negative 7. So if I put in there x minus negative 7, and let's even write it out, we'll just do this step by step, plus y minus k, minus the y coordinate, -4, quantity squared, equals, our radius is 7. You know, over here is r squared, so that's going to be 7 squared. And let's just clean up our signs. X minus a negative, we add the opposite, plus. X plus 7, quantity squared, plus. Y minus -4, minus a negative, that becomes y plus 4, quantity squared, equals 7 squared is 49. And we're done. They asked us to write the standard form of the equation. Here is standard form. Our center is -7, -4. The square root of that is our radius. Okay, and example 8. Find the equation of the circle. It looks like it might be a little more work here. The point 3, 4 lies on the circle that has this center, -1, or +2, as shown in the figure. Write the standard form of the equation of the circle. Well, let's see how much of it we know right now. X minus h, quantity squared, plus y minus k, quantity squared, equals r squared. So they did give us the center. You know, the center is right here, -1, +2. So we could plug that in. X minus, our x coordinate is -1, so minus a -1 would be +1, quantity squared, plus y minus k. And our y value is +2, so we just plug it right in. Y minus 2, quantity squared, equals radius squared. What is our radius? Well, they didn't give it to us. They gave us the center of the circle, and they said this point is on the circle. So if we look at the figure, here's our center at -1, 2. Here is a point on the circle. If we connect the dots, like it is so with the little dotted red line there, that would be our radius. How do we find that length? Well, we're going to have to use the distance formula. Good thing we learned that in section P7. So, back to the distance formula. Distance equals, remember, under the radical, we subtract our x values and we add the subtraction of our y values. So if I look at these points here, let's see here, we got them written right here. So it's x minus x first, -1 minus 3, -1 minus 3, and then we would have 2 minus 4 in the other parentheses, y minus y. So -1 minus 3, we add the opposite. That would be -4, quantity squared, or 16. Plus 2 minus 4 is -2, and -2 squared is +4. If we add those together, we get the square root of 20. And that is our distance between, or the radius. Remember, for standard form, though, which we are writing here, we want our radius quantity squared. So we plug that square root of 20 in. What do the square and the square root do to each other? Well, they're going to cancel each other out. So we're going to have our standard form is x plus 1 quantity squared plus y minus 2 quantity squared equals the square root of 20 quantity squared is 20. And there's our standard form of the equation. Practice time. In the first two, it says write the standard form given the characteristics. Here's your center. Here's your radius. Write the equation. Here is the center of the circle. Here is a point on the circle. So this is just like the example we just did, the last example for 66. In the last one, they're giving us a standard form. They want you to find the center and find the radius of the circle. Do a quick sketch of the graph. So pause the video, give them a shot, and then check your work. Alright, let's see what we can do here. Standard form of the equation. This is an easy one. You know they give us the center, 0, 0. The radius is 5. So it's x minus the h coordinate, or the center's x coordinate, x minus 0 quantity squared, plus y minus the k coordinate, the y value of the center, which is again 0, quantity squared, equals r squared, or 5 squared. Well, x minus 0 is x, and that quantity squared is x squared, plus y minus 0 is y, and that is also squared. So we have x squared plus y squared equals 5 squared is 25. Alright, not a bad one. Just plug it in there and go. Now this next one we are going to have to work a little bit for, just like the last example. So we can get started by writing our standard form. X minus the h, or x coordinate, is 3. Quantity squared, plus y minus -2 would turn that into a +2, quantity squared, equals radius squared. But we do not know the radius, but we have the center and a point on the circle. So if we find the distance between 3 and -2 and -1, 1, that will be our radius, and we can plug it right in. So distance formula: x minus x, 3 minus -1, quantity squared, plus y minus y, -2 minus 1, quantity squared. So 3 minus -1 is plus 1, that's 4. 4 squared is 16. Plus 2 minus -2 minus 1, we add the opposite, get -3, and we square that, which is 9. 16 plus 9 is 25, and the square root of 25 is 5. So that goes in for the radius. That would be 5 squared, or we could just plug the 25 right in. 5 squared is 25. There's our standard form of the equation. All right, and the last one, find the center and the radius. This has a slight twist to it. The center of the circle is a point, x comma y. The y coordinate is right here. Remember, I sort of said flip the sign. If that's a -1, you bring it down as a +1. But what about here? It's just x squared. Sort of like what we did in the first example. Could we rewrite that as x plus 0, quantity squared? Yeah, that's the reverse of what we did in that very first problem in the huddle, whatever number that was, 62. So our y, or our x coordinate of the center is 0. 0, 1 is the center, and remember this number here is radius squared. So if we square root that, the square root of 1 is 1. So the radius is 1. And if we do a quick sketch, the center is 0, 1, 0, up to 1, and the radius is 1. So if we are centered at 1, you know we're going to go up 1 more unit to 2, or down 1 unit to the origin, 1 unit to positive 1x, or also to negative at 1x here, and that would be our circle. Come down, touch the x-axis right at the origin, and then back up and around. And that is the end of 1.1, functions and their graphs. Last night's homework was a worksheet. For tonight, it is some problems from the book. Page 86. Here's your problems. Pay special attention to the even numbered ones.